Okay, guys, we're in advanced math trig honors class, mods 2, 3, and 4. We are in the last day of our exponential / logarithmic chapter. Top left corner of your paper, go ahead and write 4/22/20. So today is Wednesday, April 22nd. Yesterday we showed you an application for all the exponential equations we've been learning how to solve and using logarithms for real life scientific type problems with the growth and decay. If you're a little more financially motivated and want to look at a savings account, or you guys are going to start taking out student loans for college or making a house payment or a car payment, any loan, any savings account, anything dealing with financial situations or money that involves compound interest, there's a formula that's used in the banking world that has exponents involved. And so certain questions you answer will involve using logarithms and solving an exponential equation. So for today's title, again, top left corner, Wednesday, April 22nd, put compound interest at the top. I would go ahead and write down like savings account, student loans, house payments, things like that. This is where you're going to use the following important formula. Now, for now, go ahead and put it in a box and kind of highlight it. If you want to put a big star by it, that's fine. But put capital A equals capital P, parentheses, 1 plus r over n, that quantity raised to the nt power, okay? This is a formula you use to calculate an account, a financial account, okay, that charges interest compounded, and then I'm going to fill in words like annually or semi-annually or quarterly or monthly or daily. And this is our famous compound interest formula that I want you to write down. Now, of course, we can't work with that and understand it at all, even though it's going to be pretty easy to work with here in a minute, if we don't clarify what all those letters stand for. Okay, the capital A on the left stands for, it's the word amount. It's the final amount of money that's going to be sitting there at the end of a certain time frame. So A is the final amount of money. Let's call this a savings account. That's where it's most seen at right now. So let's say capital A is the final amount of money you're going to end up with in your savings account after a certain amount of time. P, capital P, is the principal amount. What that basically means, go ahead and write down in parentheses the word it's the original amount that's getting placed, let's say, into a savings account. So P is the principal amount, the original amount you're putting into a savings account. The final amount that you're going to have in your savings account after so much time has passed is represented by A. R, of course, is the interest rate that bank is going to give you for the money you're putting into that savings account. Now, I'm going to make a note here. That interest rate is always written as a decimal, in this formula. N stands for the word number, and what they mean by number is the number of times per year. The number of compounding intervals per year that they're going to stop and calculate the interest on the account that you're creating. Okay? So if they say semi-annually, that'd be what? Twice a year. If they say quarterly, that'd be every 3 months, right? Quarterly, so that'd be 4 times a year. If they said monthly, it would be 12 times a year. If they said daily, that's not going to happen. But then N would be 365, because daily would be 365 days a year. T, of course, is the total amount of time that the money is in the bank, the total amount of time that you're going to use to maybe pay back a student loan, right? To see how much money you're going to owe them in the end, okay? Or to pay back a house payment. If you have to borrow money to buy a house and you go to pay stuff back and it's interest compounded, let's say quarterly or monthly, then obviously the final amount of money you're going to end up owing the bank at the end of the 30-year loan. Oh, my point is time is always calculated in years when dealing with compound interest. So for some reason, you're going to establish a savings account and then leave the money in the bank for only 6 months and then take all the money out of the account. When you calculate how much money you're going to be in there that you get to take home with you, the time would not be 6, even though it was 6 months. 6 months, of course, is a half a year. So 0.5 would be the time. Okay? With that formula in mind, I'm just going to pose a simple scenario to you. Okay? Everybody go ahead and write this scenario down, or this question. Let's say Grandpa gives you or gave you $2,000 as a gift on your 15th birthday. Okay, so first note you're going to make, Grandpa gives you or Grandpa gives me $2,000 for your 15th birthday. But there's a condition. He says you got to leave this money in the bank for the next 3 years and let it grow and grow and grow in a savings account because you're accumulating compound interest, and then take it out on your 18th birthday after 3 years, and use it to help pay for your first year of college. Okay? So the scenario again says you must leave it in the bank. You must leave it in the bank for 3 years. Which bank is going to be the better option? So my question is simply, if you took that $2,000 from Grandpa and you had to go put it into a bank somewhere and let it save and develop interest and grow, which of the following banks, which bank is better? Okay? Now, just to compare the two banks, let's say you got to make this decision. Kind of think about your instinct here. Which bank do you think you should go with? Now, of course, you don't want to just guess and hope that you go to the right bank. Wouldn't you love that money to sit there and grow and make the most amount of money as possible? You might as well make an informed, educated decision here. So Bank A, whatever the name of it is, they offer a 7% interest rate, and your interest is compounded quarterly. Okay? Bank B, trying to get your business as well, they tell you, hey, we've got a 6% interest rate, but we compound your interest, calculate your interest monthly. Which bank do you think would be the better option? Or are they going to end up being about the same? Of course, if you're in the marketing department, you're reading this bank's advertisement, they're going to say, oh, our interest rate is higher than theirs, so come with us. They're going to talk to you and try to convince you and say, hey, yeah, but we compound or calculate your interest monthly, whereas that bank only does it every 3 months, quarterly. So come with us instead. You would like to be able to make an informed, educated decision as to which one you should go with. So let's give it a shot and see which bank would be the better option. Okay, following my formula up top, I'm just going to follow the numbers or the letters that get plugged in here. Bank A, okay, the final amount of money is going to be, now the principal amount of money, the original amount, of course, remember Grandpa gave you $2,000, times, I'm following the formula you wrote down, 1 plus, okay, careful, R stands for interest rate. This bank pays 7% interest. Don't put 7. Put 0.07. Remember the note I made that interest is always as a decimal. So 0.07 over, I simply took that decimal point and moved it 2 to the left to create that 0.07, over N. N means the number of times per year they calculate your interest. Since this bank does it quarterly, that means they do it 4 times a year. Raised to the NT power, well, we've already said N is 4 times T is the amount of time that the money's in the bank. And remember, in this problem, we're leaving it in the bank for 3 years. You're going to take it out when you turn 18. So times 3. So obviously, we don't need to solve an exponential equation here. I'm just kind of giving you a feel for how this formula works. It's pretty interesting. You're going to need your calculator. Now, guys, remember, don't try to type too much in at one time on your calculator. If I had to give you advice right now, I'm looking inside those parentheses and I am typing 0.07 divided by 4. I'm hitting enter, and then plus the 1 that's in there, and hit enter. And inside that parenthesis, I'm getting 1.0175. Agreed? And that's raised to the 4 times 3, which is to the 12th power. So since that number, 1.0175, is on my calculator screen, I'm going to hit raised to the 12th power, which gives me 1.23 blah, blah, blah. It's some number on my screen that I'm now going to times by 2,000 and end up with, a final amount, interesting, of what? $2,462. And since it's 0.878, it would round off to 88 cents. Another reason we always rounded logarithms and exponents to the nearest 3 places, because we're using in the financial world and we want to go to the nearest 0.88. Since the third number was an 8, that 7 rounded up to 88. 2462.88 is how much money you'd have sitting in that bank account after 3 years. So you would have made what? $462.88 in interest. Now go to Bank B. They offer a 6% interest rate compounded monthly. Well, let's use the same formula. We're still going to look for our final amount. The original amount is still $2,000. Inside, we've got 1 plus. Okay, now concentrate. You don't want to mess up numbers when dealing with money here. You're going to get in trouble if you work at the bank and you mess this up. The interest rate was 6%, so that's 0.06. They calculate your interest monthly. Oh, every month. So that's what? 12 times a year. So my exponent, since it's always n times t, is going to be 12 times again. We leave it in the bank for 3 years. So cleaning this up, we've got 2,000 times. Okay, again, I'm going to do what's in parentheses first on my calculator. 0.06 divided by 12, enter, and then plus 1. Should be getting 1.005. Notice that's what? Smaller than the number we got in parentheses over here, but I have an exponent of 36. Is that enough of a difference to make up for the smaller interest rate? Let's see. So I'm taking that number on my screen, 1.005. I'm going to raise it to the 36th power. End up with a number on my screen that I'm now going to times by 2,000. And moment of truth, Bank B, you'd end up with $2,393.36 in the bank. So if you would have picked, if your instinct was I'm picking Bank B, you would have ended up what? Cheating yourself out of 62 plus 7. It would have been $69 less to take out of the bank than if you would have picked A. So A was the better bank. Apparently that little bit higher interest rate was a little more important than how often they calculate that interest. Okay? Interesting how the dollar amounts would be in each bank account after 3 years. Okay? Now, how would you use this in an exponential equation solving situation? Our last problem of the day. Watch this. Let's say you've got $4,000 that you want to put into a savings account, and you go to your bank and they pay a 5% interest rate and they calculate your interest monthly. And I'm going to pose this question. How long would you leave the money in the bank if you want to make $400 in interest? So guys, you got $4,000. You're putting it into a savings account. All right. It pays 5% interest rate, calculated monthly. How long do you think you'd have to leave that money in the bank until you make $400 in interest? So let's just say you're trying to make $400 easy dollars to help pay for something you've got in mind that costs about $400 to buy. So instead of going out and working for $400, you're going to take the $4,000 you've got, invest it, And I wonder how long that money's going to sit in the bank until I make $400 in interest. Okay? So think about it. If we go back to our formula, our final amount, remember this formula, A equals P times 1 plus R over N to the NT power. You got to think, right? You're a banker now, okay? Not a scientist. A, remember, stands for final amount. Well, if we've got $4,000, we're putting it into the bank in the savings account, and we want to make 400. Oh, doesn't that mean the final amount's going to be 4,400 at the end? Because that was our goal. Of course, the principal or original amount is 4,000. We've got 1 plus, we know the interest rate at this bank was 5%, so 0.05 over N. Remember, N means number of times per year they calculate your interest. Since it's monthly, that'd be 12 times a year. And this is the 12T power, right? Because we don't know how much time it's going to sit in the bank. Oh, so if you're the banker and someone came in and asked you this, okay, you're one of the accountants at the bank, and a lady says, hey, I've got $4,000. I'm going to bring it into your bank, set it into an account. How long until I'm going to make $400 in interest? That's the kind of question you would have to answer for this customer. Now, careful, look at this. Isn't our goal to solve for the letter T and it's a missing exponent? So I hope your brain's thinking, when in doubt, log it out. But don't do that yet. That's a dot connected 4,000. I'm going to divide by 4,000. So on my calculator, I'm hitting 4,400 divided by 4,000 and getting 1.1 equals, now I might as well do what's in parentheses first here and combine those values. I'm going to push 0.05 divided by 12, hit enter, and then hit plus 1, hit enter. That's really 1.004 to the 12T power. Oh, and now that I'm looking for a missing exponent, the only way to solve for T is to log both sides, right? Now, I could ln both sides if I want, but I don't have to use natural log since there's not an E involved. Do you agree? So I'm going to log both sides. I've got the log of 1.1 equals the log of 1.004 to the 12T power. Then I'm going to move to the front like we've always done. All right, guys. Now there's a dot connection here, so I'm going to divide by the log of 1.004, divide by the log of 1.004. Those would cancel, and I've got 12T equals, how about that? You were sitting there working at the bank, and you got to pull out a calculator and use the log button. Who would have thought it, huh? You got log 1.1, enter, divided by the log of 1.004, enter. I'm getting 23.875, right? Divide by 12, and T equals, when I divide by 12, I get 1.989, so basically 1.99, which would be about what? You would tell that customer, if you just sat that money in the bank and left it sit there for 2 years, you'd eventually make $400 in interest. Or vice versa, if that's money you're borrowing that you have to pay back to the bank. All right? After 2 years of paying off this loan, they let you borrow $4,000 and you ended up paying them back $4,400. So the bank made $400 by letting you borrow the $4,000 originally, and you had to pay them back $400 more than what you borrowed. It can go both directions, okay? Now, guys, interesting, kind of cool. If you end up getting into banking or accounting or finance, financial advisor, things like that, you start to use formulas, again, that involve exponents, and you might have to go back to good old logarithms to help answer some questions and figure some things out. That's just kind of an interesting way to end the chapter. It's not a state documented part of the curriculum. It's just something I wanted to end things with to show you that is actually pretty useful for you guys, since hopefully you're saving some money or going to have to take out some loans and buy a car and a house and all that. You might as well get exposed to how that kind of thing works. So good news. You did a great job. You watched the video. You took your notes. There's no homework tonight. Take the night off homework-wise. Exhale. You're all caught up through Wednesday the 22nd. We'll start our next to last chapter of the year tomorrow on Thursday the 23rd. So we will see you then. Great job. I hope you found that interesting and useful, and we'll start a new unit tomorrow. See you then.